Thank you. So firstly, I would like to thank the organizers for this event and also the participants that you're staying a bit late. Today is Friday afternoon, so I will try to complete the presentation in time, so you'll be then free for the socializing event. So the topic that I'm going to present today is deep learning for predictive alerting and cyber attack mitigation. This is a research paper that I have prepared. This is not working, or there? I'll use this one. Okay. This is a research paper that I've been prepared as a part of my PhD studies at Arbnor University of Technology. So besides my PhD studies, I am also a Chief Information Security Officer at ProCredit Bank Kosovo. But at the same time, I'm working as a cybersecurity researcher at SENS NGO. So without further ado, let's continue. So initially, I will start with an introduction to the topic, to the paper that I'm going to present today. Then I'll go a bit through the related work that have been done in this field. After that, we'll focus a bit in this predictive alerting as a model that's being used to detect anomaly behaviors. Then part of this paper was also some experiments that we have conducted in order to test this machine learning algorithm that we have included in the paper. And as a final, we'll do some conclusions related to this paper. So now, as we all know, we are living in the fourth industrial revolution, where the problem is not anymore to get connected to this virtual world, but the problem is how to secure ourselves in this cyberspace. So what are the challenges in this field? So in general, the main challenges in cybersecurity derive from the complexity of cyberspace and this rapidly evolving techniques and tactics of cyber threat actors. As we all know, it's not a matter if we are going to be attacked or hacked, but it's a matter of when we are going to be hacked or attacked. Therefore, the main objective is to minimize and control the damage caused by cyber attacks and incidents, to provide, idea is to provide an effective response and recovery, and also to prevent future incidents from happening. Let's talk a bit, in this case, regarding cyber threat intelligence. So what cyber threat intelligence? The main idea is to proactively protect our system. So it's not a matter just to deal with incidents when they happen, but the idea is to fight with them, to look for them before an event happens in the organization. Cyber threat intelligence in general uses data mining and machine learning techniques, which aim to transform the processed data from large data sets, from large sources, that feeds that we get, into knowledge, into information. So part of this is this predictive alerting as a method that's used to check for the historical data and real-time data in order to make this connection and at the same time to predict the future threats and attacks that might occur to our organization. So the main challenge here, as you can see, is to transform this huge amount of data that we collect from lots of sources into actionable intelligence. So the idea is to have the actionable data, not lots of sources of information, then we get lost on it. So this is the main focus of predictive alerting in cybersecurity. So what's the motivation behind this research? As I mentioned at the beginning, I'm currently doing the PhD thesis, which is threat intelligence and situational awareness in cybersecurity, with the focus of cyberspace in Kosovo. Therefore, the idea was to test a new protocol, a new, in this case, machine learning algorithm, in real case scenarios and to see how it compares with other machine learning and data mining algorithms. In this case, we used deep residual neural network as a model and compared it with sequential rule mining, intrusion detection tree, intelligence, intrusion detection model, and ScaleNet. These were the 4 models that we compared our model that we used for these experiments. The model that we used, deep residual network, is used in the image processing, and we wanted to see its performance in cybersecurity. So in order to analyze and to evaluate its performance, we needed to compare it with some actual machine learning algorithms that are used in cybersecurity. In this table, I have put the 4 main papers that have been focused and the 4 main methods that have been used in this predictive alerting in cybersecurity. The first one was sequential rule mining approach from author Martin Husak. In this paper, and this method had a very high successful, rate of detection, but failed to train machine learning algorithm to automatically detect the good rules. The second method that was used to compare our method, is intrusion detection tree. Which it was like very good in terms of computational cost, in terms of using the power of processing, but in general it had the lack of generalization approach. The third method that we compared was intelligent intrusion detection model. This method effectively reduced the computational complexity in this case, but failed to consider filtering and wrapping method for better performance. So it couldn't achieve better performance. And the last one was deep domain generation algorithm by author Vinaya Kumar. This approach provides very detailed information about the malwares, but it wasn't tested on real environment. So these were the 4 methods that we compared our model. So main contribution here is to predictive alerting is to provide, as I mentioned at the beginning, actionable and prediction of alerts based on this machine learning algorithm by processing different sources of information, data sets, etc. So what our proposal was, and the experiments we conducted, was deep residual network predictive alerting. It was used as a plugins, and these were integrated in the Sabu platform. Sabu platform is a platform used in Czech Republic, which is developed and maintained by an academic entity in the Czech Republic, and it collects feeds from third party, from honeypot, from intrusion detection systems. Then it has a database called NERD, which calculates the reputational scores for network entities. Is similar to Shodan, and also it has this Mentat where users can register to this platform and get the feeds according to their IP addresses and indicators they want to receive. And this iAbu is an analytical component that is used by the administrator of this platform. So what we did, we used this threat intelligence sharing platform, and we integrated 2 machine learning algorithms that weren't tested before. So we integrated for alert segregation fuzzy C-means clustering, and also for alert prediction we integrated as plugin this machine learning model called deep residual network, which I mentioned is used in the image processing. So it was the first time to test it in the cybersecurity. How we did this? So there are some stages in this Sabu threat intelligence system platform. Firstly, we get the input from that data set of this threat intelligence by normalizing. Firstly, the first step is to normalize data set and in one unified format. The second stage was here to normalize them together with the inputs that we had from logs. In the situational awareness, here we used fuzzy mean clustering as an algorithm where we provided this as a plugin to the platform. So we use this Sabo platform and we use this as a plugin with our protocols, machine learning algorithm that we wanted to test. Third stage, after we did clustering groups of information, we used feature selection. In this case, we used the Helifinger distance to identify, the feature selection in this case. Third and fourth stage was threat intelligence engine. Here we included the machine learning model that we wanted to test. And at the end, we did blacklisting by blacklisting the suspicious IP addresses based on this whole process. So I just explained this theoretically how we did the experiments during this research paper. So how we did the experiments, we used the Python programming language, database from, this is the Sabo platform, specifically the Warden server, where these information are collected. Currently, it has 34 gigabit of information. There are 10 million events. There are 25 senders and 33 receivers. During our test, we used nearly 12 million alerts generated by 34 intrusion detection systems, honeypots, and other data sources that we can see here in this design. So these were the information that we used to make this test of this machine learning algorithm. Here you can see the results. There have been several tests, several iterations. Firstly with 60% of trained data, then with 70% of trained data, 80% of trained data, and until 90% of trained data to analyze the performance of this deep residual network predictive alerting by using this three main performance metric, which was precision, recall, and F measures. As you can see here are explained the what does these measures mean. Well, precision, we have false positive, true positive, then we have relevant event. Precision means the total number of true positive divided by the entire true and false positive. Then recall, we have a number of true positive divided by relevant events, number of relevant events. The results here are with each iteration. Firstly, with 10 iteration, we tested all the metrics, all the performance metrics, with 15, with 20, and 25 iterations. So this test was conducted only for deep residual network algorithm. What we did next, we wanted to see how this machine learning algorithm compares with other relevant machine learning algorithms that I mentioned in the beginning of presentation. So what we did, we tested also all of them. We integrated them as plugins to the Sabo platform, and we tested with 60%, with 70%, 80%, and 90% of trained data. And as you can see in the result, the deep residual network machine learning algorithm outperformed the other algorithm in terms of precision, recall, and F measure. As you can see, the first is around with sequential rule mining, there is around 15% better performance, 80 with 95. With intrusion detection tree, it's around 14% better with second machine learning algorithm. There is with the intelligent intrusion detection model is 10% better performance. And in ScaleNet, that was the best performed out of these four, it's around 8% better performance. This is only for precision, as you can see, for recall the same, and for F measure the same. So this protocol provided better, this machine learning algorithm provided better results than the others in detecting and predicting cyber attacks. So as conclusion, the use of machine learning in threat intelligence analysis, as you can see, can improve the efficiency, accuracy, and effectiveness of threat detection and response, which in today's fast evolving threat landscape is very critical, as you all know. The proposed model that we used enhances the performance of generalization, and also it used less processing time when we use this ReLU function, activation function, which was better than tangent and sigmoid function, some mathematical functions that are used to test the performance. The idea as the alert segregation fuzzy means that we used also provided very effective in clustering the groups, the threats, and as a future work, of course, we can improve this protocol by testing it with a higher data set and also in live environment. So this was in general, I tried to be quicker than I planned because it's Friday afternoon, there's a socializing event, so I didn't want to stress you more. If you have questions, you can address them directly, or you can contact me through the email address.
Thank you, Arbnor. Does anybody have any question? Okay. You're gonna make me walk up there. That's fine, no problem. There you
go. So just out of curiosity, I'm not going to name company names. I don't want to go that route. But so when I'm doing detection bypassing and such, so let's suppose that you have some type of threat detection mechanism that uses AI. The ones that I see often used have a long spin-up time. So they learn a company or even a person's behavior. They learn what's normal, and then they can detect what's abnormal. The downside to this, of course, is that at the very beginning, everything is abnormal, right? The LM or whatever you're using has to be trained up. So I guess my question is this something that can be user-friendly? So if you're trying to train up an AI to detect any type of malicious behavior, are you basically looking for anomalies or anomalous behavior? Or are you looking more for machine code or other things? How are you detecting it, and do you see this impacting the usability of somebody's day-to-day operations?
Well, in general, these methods goes in combined with other techniques because, of course, there are lots of false positive rates in this case, and that's the main challenge in this field. So it tries to get the best results, but of course, in this case, you have lots of false positives, which then you need to combine with other techniques in order to have a more accurate results in predictive alerting.
Is your research available online or?
Yes, Ariane, it's in IEEE Explore. It's published. It was part of a CCVC IEEE conference. I presented there, and it's available in IEEE Explore.
Great. Thanks so much. Any other question? Yeah.
Is this project implemented somewhere? You mentioned in Czech Republic.
Yes. In fact, similar idea I am trying to implement in Kosovo in National Cybersecurity Unit, which is called COSCERT. So the idea started from here when I started when I initiated the studies in cybersecurity. I saw such kind of project, then I saw it as a possible to be able to be integrated in the Kosovo. So currently with some of teams from research center, we are trying to implement similar solution in Kosovo, and at the same time to integrate that algorithm in order to achieve better results.
Great. Any other question? Arbnor, thanks so much. That was very informative.
Thank you very much.